teleconference over to Dwayne Brown. Thank you, sir. Please begin.
Thank you, operator, and happy Friday to everyone. I want to thank folks for joining us. This is a great day for NASA and for humankind with the first spacecraft to successfully enter orbit around a dwarf planet. Today, you're going to hear how that happened, why it's important, and why it is so historic in nature. We're going to have three folks on the call here. First up, you're here, Mark Raymond, the Chief Engineer and Mission Director for Dawn, will give you the specifics on how this historic achievement happened today. He will be with us for about 15 minutes, and then he's got to go off to take care of some other business. But if there's any other questions directly associated with the engineering and the process of getting in orbit, we can certainly do follow-up interviews with him. Following Mark will be Carol Raymond, the Dawn Mission Deputy Principal Investigator at the Jet Propulsion Laboratory in Pasadena, and Mark is also at JPL. And following Carol will be Jim Green, the Director of the Planetary Science Division here at NASA headquarters, with his portfolio, everything going on. This is just the beginning of several months of incredible science, discovery, and exploration. This call will be replayed in its entirety until Wednesday. That call-in number to hear this entire teleconference is 888-562-0226. And again, I want to thank you. If you have any other questions, my name is Dwayne Brown with the Office of Communication. So let's get started, and let's start out with Mark.
Well, thank you. So we're here to talk, as you heard, about the first exploration of the first dwarf planet. So Ceres was discovered in 1801, and it's beckoned for more than 2 centuries. And finally today, Dawn answered that cosmic invitation. So it's using its advanced ion propulsion system, which I actually first heard of in a Star Trek episode from the logical Mr. Spock. And using it, it's flying a complex and elegant course into orbit that I think would be the envy of any crackerjack spaceship pilot. So at about 4:39 a.m. Pacific time today, Ceres reached out and tenderly took Dawn into its permanent gravitational embrace. So the spacecraft is in orbit, and it will spend the rest of its operational life there and will be there long, long beyond. Now, because it's using an ion propulsion system, the way it enters orbit is very different from what you normally think of. You tend to think of there being a spacecraft coming screaming up at high velocity, executing a whiplash-inducing, bone-rattling burn to drop into orbit. But Dawn does it differently. This ion propulsion system is fantastically efficient, 10 times the efficiency of conventional chemical propulsion, but it's also very gentle. And in fact, if you hold a single piece of paper in your hand, the paper will push on your hand as hard as the ion engine pushes on the spacecraft. And so the spacecraft just gradually, elegantly, gracefully crept up on Ceres and slipped into orbit. And so you also tend to think of there being a room full of tense, anxious people biting their nails, waiting to know whether there's going to be success or failure, but that's not the way it worked today. Mission control was empty. We weren't anxious or concerned. If there had been a glitch, which there was not, we could have gotten into orbit some other day because the ion propulsion system gives us fantastic maneuverability. So in my mind, the drama isn't in whether the mission will succeed or fail, whether there'll be a single glitch that could cause a catastrophic loss, or whether even a tiny mistake could spell doom. Rather, the drama is in the opportunity to unveil the wonderful secrets of the largest unexplored world in the inner solar system. And so today, when Dawn went into orbit at about 38,000 miles altitude, as it and Ceres were traveling together around the sun at nearly 39,000 miles per hour, that's what happened. So that's just a little bit of an overview, and now I'll turn it back to Dwayne.
Thank you, sir, and congratulations. And Carol.
Hi. We are really excited to be beginning this historic exploration of dwarf planet Ceres, which we also refer to as a protoplanet. We think of Ceres and Vesta as building blocks of the terrestrial planets, and they represent about 40% of the mass of the entire main asteroid belt. So together they are very different objects than most of the other material there, which is largely collisional debris that's left over from the violent scattering of material by Jupiter's gravity field. Excuse me. We'll be beginning our 16-month investigation of Ceres, in which we're going to spiral ever closer to the surface, executing a series of 4 science orbits. Our first science orbit will begin on April 23rd at about 8,400 miles from the surface. And between now and the start of that orbit in April, we will not be getting any more images because we are swinging around the dark side of Ceres at the moment. When we do get into that first science orbit, we'll get much better views of details of the surface. We'll watch Ceres rotate again from several vantage points, and we'll be able to look at the illuminated disk of Ceres to look for any material which might be lofted off of the surface by gases escaping from Ceres itself. So that will be an opportunity for us to follow up on the detection of water vapor near Ceres, which was made by the European Space Agency's Herschel Space Observatory and was reported in 2014. After the RC3 orbit, we'll spiral down to our first mapping orbit at 2,700 miles altitude. And there we will be getting a very detailed look at the minerals of the surface as well as the geologic features. We carry, in addition to cameras, which everybody is knowledgeable about from the fantastic images which have been returned, we also have an infrared spectrometer and a visible channel spectrometer, which are going to allow us to make very detailed maps of the composition or the minerals on the surface. And those allow us to infer processes that are going on below the surface and via the impacting processes that leave evidence behind on the surface. After that complete global mapping with our spectrometer, we spiral down to an orbit which allows us to get very detailed shape information, basically build a topographic map of the surface and start mapping the geologic features in exquisite detail. And then finally, we spiral down to just 230 miles above the surface of this body, which is 600 miles in diameter, and we map its elemental composition, its gravity field, and look at surface features as small as 40 meters across. So by the time we finish in mid-2016, we're going to know Ceres in exquisite detail. We're going to understand why it has bright, very, very bright spots which are unique to any body in the solar system that's been explored thus far. And we're going to understand what Ceres means in terms of a building block for planets in our solar system. And back to you, Dwayne.
Thank you. And now to Dr. Jim Green, Director for Planetary Science Division here at NASA headquarters. Jim?
Thank you, Dwayne. You know, DAWN is not an acronym. You know, NASA loves acronyms, but DAWN really refers to a mission that's going back in time. It's visiting a region in the asteroid belt. It's been at Vesta, as was discussed, and now at Ceres, the number 1 and number 2 sized bodies in the asteroid belt. And that whole area has been the same for billions of years. It's a region where a planet should have been, but no planet was created. It's a region where Jupiter's gravitational interaction with this region has kept these pieces apart. Ceres, that protoplanet, that beginning seed of a planet, now allows us to look back in time to see how terrestrial planets are put together. It's spherical, which we now know means that it is gravity and its heat inside due to radioactive materials that it has created is allowed material that is heavy to sink to the bottom, probably has a core that's fairly extensive, silicate rock crust, and now we know extensively about its ice shell, but we need to know much more about it. Its ice shell surrounds the body, and it is a beautiful, beautiful example now of our dwarf planets, those things that are building blocks of planets. So Dawn is just such a wonderful mission to explore that early part of the solar system because it's right here in front of us today. What we learn about from Dawn, about our building blocks, about this region, about these asteroids, I'm sure will also inform us about other solar systems and how rocky planets are created in those locations around other stars. So it's a tremendously historic mission, and we're delighted it's there safely, and we can't wait for the science results to come out. So with that, let me turn it back over to Dwayne.
Thank you all. Before we go into the Q&A, just a couple of follow-ups here. For Mark Raymond, his name was not listed on the advisory, let me make sure you all have his spelling right. It's M-A-R-C-R-A-Y-M-A-N. That's M-A-R-C-R-A-Y-M-A-N. And again, Chief Engineer and Mission Director for Dawn at the Jet Propulsion Lab. And I may have given out the wrong information on when the pictures will actually be taken. Mark, did you want to clarify when the pictures will come in or start?
Yes, as Carol or somebody said, we're on the dark side of Ceres now, so we're using a combination of Ceres gravity and the ion engine to sort of pull Dawn back towards Ceres. And so we're not taking pictures now, but we will resume taking pictures April 10th. And so we'll take pictures a few more times before we get down to this first 8,400-mile altitude intensive, or this orbit at 8,400 miles from which we take intensive observations.
Thanks for clarifying that, Mark. My mistake on that. So I know Mark is going to have to leave us. He has other commitments. But again, if you have any specific engineering questions, we can get to those at a later time today if we don't have the answers. So with that, let's go ahead, operator, and transition into the Q&A.
Thank you. At this time, if you wish to ask a question, please unmute your phone and press *1. Again, that is *1 if you wish to ask a question. One moment, please, for questions to queue. Again, that is *1 for questions. One moment. We have one question on the line. One moment. Our question will come from Ken Kramer. Your line is now open.
Oh, hi, thank you, and congratulations to the Dawn team and NASA for a fantastic result today. I wonder if you could talk a little bit about what will the spacecraft be doing in the next few weeks before you take images. Talk a little bit more about when you'll also be activating the science instruments. And I think you released one picture today. Are there any others we can expect from March 1st? Thanks.
I can take part of that with regard to what the spacecraft is going to be doing. It's continuing to use its ion propulsion system to reshape its orbit now around Ceres, aiming for this circular polar orbit at 8,400 miles. And in the meantime, it's now going up to a higher altitude. So when it was captured, it was around 38,000 miles in altitude. But on March 19th, it will be at the apex of its orbit, the apogee, a term I know you know, Ken, of nearly 47,000 miles. So it's continuing to thrust. It's reshaping the orbit, changing the plane of the orbit because we want to fly over the poles by flying over the North Pole, then south toward the equator, and then over the South Pole. As Ceres rotates underneath the spacecraft, it gives us a view of the entire surface. And so there's a lot more maneuvering ahead so that we can begin taking the detailed science observations. We're also, we've used both the camera and the combination visible and infrared mapping spectrometer, but we have not yet turned on the gamma ray spectrometer nor the neutron spectrometer. That is, we haven't turned them on here at Ceres. Obviously, we've used them extensively before, and so that's going to happen soon as well.
So as far as the better image data, we do have two op-navs before we get into the RC3 orbit. But as I said before, the RC3 orbit is when we will be seeing a big change in our understanding of the surface of Ceres.
Were there any other images from March 1st? That's what I was wondering.
Oh, no. The images that were released, not every image was released, but they're similar to the one that was released.
So there's not going to be a rotation movie or anything like that. Okay, thank you.
No, it was a more limited image acquisition for optical navigation purposes.
All right, thank you.
And as a reminder, if you wish to ask a question, please press *1 now. Our next question will come from Mike Wall. Your line is now open.
Yeah, hi guys. Thanks again for actually doing this, and congratulations on this big milestone. I just had a question. You guys went into a little detail about what the science is going to attempt to answer. But yeah, I mean, are there any things in particular that you're looking forward to, Carol or Mark? Are there any particular questions you're sort of most excited to try to learn the answers to? Would it be the bright spots, the plumes, anything in particular?
Yeah, I'll take a shot at that. So the bright spots and the plumes are really kind of symbols of what we're after at Ceres, and it's really to understand how a body accreted from the solar nebula, how it came together from the primordial protoplanetary disk, and then what processes acted on that material to the body that we see today. And the body we see today, as Jim was describing, we know it has an ice layer because its density is so low compared to rock that we know that it still has rock and ice. But we don't know in what proportion. So we don't know how much of the water came out of the hydrated rocky chondritic material. And so we're after the interior structure. Did Ceres heat up enough that it has a very dry interior with increasing hydration towards the surface, or was there a process by which most of the water was removed without causing a lot of dehydration of the rock? Or so the comparison would be: do we have sort of the leftover hydrated rock with just the lightest watery ice coming up to the top, or did we fully dehydrate part of that rock? And that's important because it speaks to what was going on at the water-rock interface in the past. We think there was an ocean on Ceres. We're based on the heat that would have been coming out of the interior, that the current ice layer would have been liquid in the past, and so that warm ocean rock interface is the type of environment that we recognize would be conducive to life, so a habitable environment. We really want to get back to better understanding what Ceres was like in the past so that we can answer these questions about its potential habitability and how a body like Ceres formed and evolved over time. And ultimately, because there were other bodies like Ceres that likely rained in on the inner planets when during some cataclysmic scattering events, objects like Ceres likely brought water to the inner planets and to the Earth. And so by examining it closely, we get kind of a window into that type of a body that may have been quite important to our own planet's evolution.
Yeah, this is Jim Green. From my perspective, when you look at Vesta, you see how cratered it is, and it's of course half the size of Ceres or so. And then when you look at Ceres, you see also heavily cratered areas, but you also see some large areas that are quite smooth. That's got to mean that the interior has communicated to the surface, and as Carol said, it's changed over time, and that's exciting. The next step, of course, when I look at it as head of planetary science, I know we're going to be flying through the Pluto system, and we're going to be looking also at other icy bodies. So that's going to be another opportunity for us to compare Ceres with Pluto. Now, Pluto is twice the size of Ceres. So there's a normal progression in sizes within our solar system that also allows us to do these inner comparisons. Their position and the raw materials where they are that they've accumulated can tell us a lot about the evolution of our solar system. And so we've got a lot to learn, and Ceres is that next step.
Thank you.
And as a reminder, please press *1 now if you wish to ask a question. One moment, please. At this time, I'm showing no further questions. I will hand the call back to Dwayne Brown for closing remarks.
Well, thank you, operator. Short and sweet. Again, I want to thank folks for listening in, and we can certainly do any follow-up interviews you may have. I want to thank Mark for giving us an update on where we are now with the images and with the spacecraft. Any images or any other information will be on the website at www.nasa.gov/dawn, and this conference call will have a replay until Wednesday at 888-562-0226. Thank you again. Congratulations to the team, and have a great weekend. Back to you, operator.
Thank you. With that, we'll conclude the conference. Thank you for your participation. We disconnect at this time.
Discovered in 1801, and it's beckoned for more than 2 centuries, and finally today Dawn answered that cosmic invitation. So it's using its advanced ion propulsion system, which I actually first heard of in a Star Trek episode from The Logical Mr. Spock, and using it, it's flying a complex and elegant course into orbit that I think would be the envy of any crackerjack spaceship pilot. So at about 4:39 a.m. Pacific time today, Ceres reached out and tenderly took Dawn into its permanent gravitational embrace. So the spacecraft is in orbit, and it will spend the rest
of this historic achievement happened today. He will be with us for about 15 minutes, and then he's got to go off to take care of some other business. But if there's any other questions directly associated with the engineering and the process of getting in orbit, we can certainly do follow-up interviews with him. Following Mark will be Carol Raymond, the Dawn Mission Deputy Principal Investigator at the Jet Propulsion Laboratory in Pasadena, and Mark is also at JPL. And following Carol will be Jim Green, the Director of the Planetary Science Division here at NASA headquarters.
Over to Dwayne Brown. Thank you, sir. Please begin.
Thank you, operator, and happy Friday to everyone. I want to thank folks for joining us. This is a great day for NASA and for humankind with the first spacecraft to successfully enter orbit around a dwarf planet. Today, you're going to hear how that happened, why it's important, and why it is so historic in nature. We're going to have 3 folks on the call here. First up, you're here, Mark Raymond, the Chief Engineer and Mission Director for Dawn, will give you the specifics on how
of its operational life there and will be there long, long beyond. Now, because it's using an ion propulsion system, the way it enters orbit is very different from what you normally think of. You tend to think of there being a spacecraft coming screaming up at high velocity, executing a whiplash-inducing, bone-rattling burn to drop into orbit. But Dawn does it differently. This ion propulsion system is fantastically efficient, 10 times the efficiency of conventional chemical propulsion, but it's also very gentle. And in fact, if you hold a single piece of paper in your hand, the paper will push on your hand as hard as the ion.
With his portfolio, everything going on, this is just the beginning of several months of incredible science, discovery, and exploration. This call will be replayed in its entirety until Wednesday. That call-in number to hear this entire teleconference is 888-562-0226. And again, I want to thank you. If you have any other questions, my name is Dwayne Brown with the Office of Communication. So let's get started, and let's start out with Mark.
Well, thank you. So we're here to talk, as you heard, about the first exploration of the first dwarf planet. So Ceres was